Okay, let's practice solving a projectile motion problem. I want you to read the problem and follow the problem solving guidelines. And keep these procedural ideas in mind. So you're going to start by reading the problem, drawing a diagram, and thinking about a problem and maybe coming up with a plan for solution. I'm going to pause the video, you do that, and then come back. Okay, you're back. Check what you did with what I did. So first of all, I drew the building, 20 meters high, and I put the projectile, and I drew a vector showing the initial velocity. And since I know the first thing I'm going to do, that's my thinking and planning, first thing I'm going to do is get the x and y components of that. Whoops, I forget to put in the angle. Let me put that in. That's important. That should have been in there. And then I estimated the path of the projectile. And then I drew a vector in the direction that it's traveling when it hits the ground. So I put in a vector indicating the final velocity. And I'm guessing exactly what the direction is. And I know I'm going to have to do this by x and y component. So I put in the x component and the y component of this vector. And I probably should have marked the angle that I'm going to have to want to find eventually, the angle below horizontal that it hits at. And I also marked what the peak height would be. The peak height, notice, this is the 20-meter height. So it's going to be 20 meters plus some little extra bit that I have to find. I also wrote down the equations that I'm going to use, the kinematics equations. Not very well written, but I crowded them in there. So I've done my diagram. This is not a force problem, so I don't need a free body diagram. And I put down the equations that I'm going to choose from, but I haven't yet come up with a specific plan as to what I'm going to do. So let's think and make a plan. So what I do know, well, the first thing I'm going to do is I'm going to turn off the video, and you can do this if you haven't already done it, and find the components Vx and Vy. So turn off the video and do that. Okay, you're back. This is what I did. I found the components, and I did one of them out. I took the equation from the equation sheet, which reads Ax equals A cosine theta, but I rewrote it as Vx initial equals V initial cosine theta. In other words, here's my V initial, it's the hypotenuse. Here's the x component I'm looking for. This is the equation I use. Then following the format, I write Vx initial equals, I put the number in, and then I do the calculation, in this case on my calculator, and I get 13 meters per second. Then I did the same thing in the y direction for sine of theta, but I didn't write it out. I'm just showing you the result. Vy initial would be equal to V initial, sine of 30 degrees. That will give you this result. Then, recognizing that Vx doesn't change because the motion in this direction is constant, I went right down here and I filled in, this is going to be 13 meters per second. It's going to start and end at the same x velocity, 13 meters per second. So now I need to think about what to do next. So think about what you're going to do next. Come up with a plan for the next step. We have the components, and we need to find all these things. We need to find where the projectile hits the ground. That means I need to get this x distance. We need to find the y component of the velocity when it hits the ground. We need to find the time that it's in the air, and we need to find this total height, so any of those things. So stop the video and think about how you would proceed at this point. You're looking at these equations for ideas. Okay, you're back, either with some answers, some ideas, a plan, or you're stuck and you're coming back for my ideas. Okay, let's remember, you see these equations, they're all written in x. But remember, ax is 0. So these equations reduce to one, in the x direction, they reduce to this one simple equation. And we don't know delta x. And so we only know Vx initial, we can't find t or delta x. So we turn to these equations written with the y subscripts. And a couple ideas come to mind. One is, if we write it in y, we can use this equation to get the time, and I'll show you how on page 2. Or, what I prefer is, since we don't have the time, use this equation to get Vy final, given that we know Vy initial, we know Ay, that's the negative 9.8 or negative 10, and we know delta y. It's off the page here. Delta y is 20. So let's go to the next page and I'll show you, I'll do both of those for you. Okay, if you don't have any ideas, here are two. Use this equation. Notice I wrote it with all y subscripts because the ax is 0, remember that? And this equation. So take this equation and find the final velocity in the y direction. And take this equation and find the time. There's a different way of getting the time, I'll tell you later, but just for practice, try doing that. I'll warn you, doing this equation, it's a quadratic. You're looking for time. So notice there are 3 terms, and there's a time squared, so you have to use the quadratic formula. It's on your equation sheet. See if you can do it. It's good practice. Okay, we're back. Notice what I did. This was fairly straightforward. Just took the square root of both sides, put the appropriate numbers in. Notice I'm using 10 rather than 9.8, so if you use 9.8, you're going to get a slightly different, slightly lower result. Using those numbers, I get 21.36. It's actually negative because it's down, so I made it negative. And that's the final velocity in the y direction, referring to that figure on the other page. Now, if I wanted to find the time using this quadratic, and if this is just too much math to you, don't worry about it. You don't necessarily have to be able to do this. But anyway, I put the numbers in without units just to save writing. Again, I'm using 1/2 of 10, so I have 5 here, not 4.9. And then I rewrite it into the form. Notice I take this equation, put the numbers in, and put it into the form of ax squared plus bx plus c, where x is the unknown, and here t is the unknown. So from your equation sheet, this is the quadratic equation, but instead of an x, we have a t, and so the b in this equation would be the number in front of the t. And that should be negative, and then it's going to be plus or minus the square root of these numbers, and you can see how I match b for a. That should be negative. There's a mistake. You see it. It should be a negative 5. So the negative 4, notice, the negative 4 times a negative 5 gives us a negative 20. becomes positive, right? So 20 times 20, this is 400 plus that. If you put it into your calculator, and then you have to plus or minus. If you make this a negative number and add it to that, and divide it by a negative number, you get the correct answer. If you choose the positive value for this, then this whole number becomes positive. When you divide it by a negative number, you get a negative time. And that's not the time we want. The negative time means something which I won't explain right now, but it does have a physical meaning. So anyway, going through this quadratic process, we come up with this time. Now, we didn't have to do this if we did this much easier process, and we have Vy final. Find an equation on your equation from your list of equations that will allow you to get the time now that you know Vy final. So I'm asking you to come up with that equation and then solve it for time and see if you don't get the same result. You do that now. Okay, lots of algebra, that's why you need to practice. So there's more than one choices, but this is the equation I chose right off the top. Notice I've written all these with the y subscript. And doing the algebra, I get that t equals Vy final. Notice subtracted that, divided by that, come up with this expression. Then I put the numbers in. So 2136 from here, it's negative. This is supposed to be subtracted, 7.5. There's my units, meters per second. And then I'm using the AY, sticking with the AY of negative 10 meters per second squared. Let's just see this. The meters per second cancel the meters in one of those seconds, leaving the units to be seconds. So I get the identical answer of t equals 2.866 seconds. If I were reporting this as an answer, I would round it to 3 significant figures. Okay, so now we have the V final. We have the time. Two more things we need to find. The delta x, the total horizontal distance, and the maximum height it gets to. So go back to your equations, think about how you're going to do that, and I'm going to proceed to a blank page to show you how to do that. But you do as much as you can before you look. Okay, with all the information we have, the last two parts become fairly easy. So I could start with this equation, knowing that ax equals 0, and I get down to this equation. Or you could just start with this, because in projectile motion, the delta x, the Vx is constant. So the delta x is simply the velocity times the total time. That's how far it'll get in the horizontal direction. And that's the result we get. It'll go 37.5 meters downfield in horizontal direction. Now finding the maximum height delta y requires some thought. A couple ways we could do it, but I'm just going to show you one here. If you did it another way and got the correct result, then your method is probably correct. So we know the total time, but we don't know the time from the top to the bottom. So I chose this equation, and I'm going to segment the problem. I can't get back to my figure right now, but I'm going to segment it. So I'm going to take the ball from the top of its path down to the bottom and use this equation. So watch. Since I'm starting at the top, the Vy initial will be 0. The Vy final we know, and the delta y we're looking for. The Ay is negative 10. So I solve for delta y. I do the algebra on this equation, eliminating this term because I'm starting, by choice, I'm starting at the top of the path, where the ball is at its peak height. I'm basically finding out how far it falls from the top to the bottom. Here's the algebra, and then I just put the numbers in. Delta y then is the 21.36, the Vy final, squared. It's negative, but it becomes positive. And this is I'm still using the 10 rather than the 9.8, so if you use the 9.8, your answer will be slightly different. So this number squared divided by a negative 20, this number should actually be negative because it's falling, so I should have a negative sign there. And that's the result. The maximum height is 2.28 meters. Now you could have found the delta y from the top of the building to the highest point, and it would have been 2.8 meters, and you could have added that to the 20 and gotten the same result. That's another way of doing it. If you try doing it that way is also fine. One last final step that I almost forgot, and that's we didn't find the magnitude and the direction of the final velocity vector. So that's the last step. I want you to think about how to do that. I'm going to let you do that. We're trying to find the magnitude. That means the speed with which it hits the ground before it touches the ground, and the direction. So pause the video and do that. Okay, wrapping things up. I hope you correctly chose the equation from the vector section for getting the magnitude from the components. You wrote the equation down. Oh yes, I haven't emphasized during this video following the formatting. You see the way I'm doing things? That's the way I expect you to do things. So I wrote the equation down. I then write the equation with the numbers. Notice the units. I didn't round this number off because I'm using it for calculation. And then I show the calculated answer here with the units and the correct number of significant figures. I hope you knew to use the inverse tangent equation for getting the direction. And formatting, you write the equation down first, then you put the equation with the numbers in. Notice I have the units. The units do cancel, I show that. The top number is negative, the bottom number negative, and when I take the inverse tan of a negative number, I get a negative angle. And if you go back to the figure on page 1, you'll see correctly that this is the angle that the projectile will hit the ground in a direction traveling below horizontal, down to the right into the ground. Okay, we're done.